Hello guys, in today's class we shall discuss about numerical relays. So we know that there is a large development occurring in the market, especially with respect to VLSI. Very large scale integration where new chips are coming into the market. Even around 3 nm chips are coming. They're not very far, future is very near. So the recent years, very high sophisticated microprocessors, even microcontrollers as well as digital signal processors are available for very less price. They are compact, faster, accurate as well as flexible when compared to the conventional relays which we discussed in your earlier classes. So numerical relays are based on digital devices like microprocessors, microcontrollers as well as DSPs. So with the latest development in the area of power system protection, so these relays which use analog signals, it may be current or voltage, which is continuously monitored by your transducers like CTs and PTs, where they're going to condition, means they're going to made usable for the numerical relays. They're sampled at any specified instant of time and again they are converted to digital form for any numerical manipulation as well as display and recording. So numerical relays are monitoring both current and voltage signals through transducers which acquire or which get the samples of these AC quantities in digital form, which converts analog to digital. And again they process the data numerically using a suitable algorithm to calculate any fault occurring in the system and also to trip the system or trip the circuit whenever necessary. So with continuous reduction in digital circuits, so costs have been decreased drastically and also the functionality as well as considerable cost benefit has improved in recent years. Nowadays, your microcontroller based numerical relays as well as microprocessor based numerical relays are widely in use. Now it has become an alternate to the traditional relaying system which we used earlier, like electromechanical as well as static relays. So your numerical relays use artificial intelligence techniques such as artificial neural networks as well as fuzzy logic systems. Nowadays they are in the research as well as in the development stage. So in future you may have only numerical relays in practice where your electromechanical as well as static relays may become obsolete. So main features of numerical relays are they are economic, they are flexible, they are self-monitoring as well as they are self-checking capability. So multiple functions like metering, communication facilities, low burden on transducers are again other features. And they are much more improved when compared to your conventional relays. So let us see a schematic diagram of a typical numerical relay as shown in the figure. So let us learn how your analog signal is converted to digital signal by using the schematic diagram. So in the figure you can see the input quantities are current as well as voltage. So it is given to the current transformer as well as voltage is given to the voltage transformers, and we know that current transformer will reduce the high current to the low current as applicable to this signal conditioner. Similarly, high voltage is converted to the low voltage and given to the signal conditioner. Signal conditioner is a place which brings the analog signal into the digitizer. That is, the signal conditioner, it will isolate the relay from the whole power system and also reduces the input voltage, whatever it is given, into the equivalent voltage as per the sample and hold circuits. So it also removes the high frequency components from the signal using analog filters. So basically it acts like a filter which removes other quantities of high frequency as well as it will reduce the signal value as per the sample and hold circuit. So output of the signal conditioner, again it is given to the analog interface, so which includes sample and hold circuit as well as analog multiplexer as well as ADC, that is analog to digital converter. It's all whole thing. So these components all together will sample the reduced level signals, it may be current or voltage, and convert the analog levels to the equivalent numbers that is stored in the memory here for the processing. So for total all these circuits, it may be your sample hold circuits or analog multiplexer or ADC, that is analog to digital converter, whole thing will process the signal and again they will convert to the digital so as to store in the memory of the microprocessor for further processing. So the acquired signals, whatever signals we have acquired here, they are in the form of discrete numbers and are processed by the, I told you already, by some special algorithm, relaying algorithm, which is able to discriminate between fault as well as healthy part and also to make the trip decisions. If there is any fault, then our microprocessor system will send a trip signal which is issued to the circuit breaker to trip the circuit. So this is how our schematic diagram of typical numerical relay works. So initially input current or voltage is given which is of high value given to the current transformer's voltage transformer, and we know that what current transformer does as well as what voltage transformer does. It will convert to the whatever quantity we have given to the lower values as per the signal conditioner, and signal conditioner further filtering is done by removing the additional frequencies as well as smoothing the quantity given to this, and again it is again given to the sample hold circuit where this analog multiplexer as well as ADC will convert the analog into digital. So it is in the form of discrete and again it is processed by the numerical relay by using special algorithm so as to discriminate fault as well as healthy and make trip decisions, which is given to the circuit breaker whenever fault occurs. Now let us see the comparison made between your traditional relays, that is electromechanical relays, as well as your numerical relays. See, in each and every aspect with respect to feature, your numerical relay stand out of this, means it is outstanding when compared to that of your electromechanical relay. It may be in terms of size, it may be in terms of characteristics, it may be in setting or memory or maintenance or anything, your numerical relay does better. You can see size, it is here bigger, it is compact. Characteristics are fixed, you can't change, but here it is selectable. You can program them or you can select as per the functions of the numerical relay. Flexibility, there is no any flexibility, but here we have flexibility of programming. We can change the program or algorithm as per our needs. Communication feature, no way, it is not possible here, but it is possible here. Blocking feature, any blocking the other activity like something what may be with the tripping or something, but here we can do that. We have that feature self supervision, or like I already discussed, but it is not available here, but it is available here. adaptability. So the system will not change, that electromechanical will not change for changing the system, but here it can change with the system condition. Multiple functions not possible, but it is possible here. Accuracy can see 5% plus or minus error it can be seen, but here only plus or minus 2% error can be seen. Speed of operation slow, here it is fast. Burden, it is high here, it is extremely low, it is good because you can have less power consumption there. And again you know that the calibration what it deteriorates with respect to time, but it is no any effect of any calibration even after use of 20 to 25 years. That's a lot. Setting and all, plug settings is there, fixed steps are there, but here software based are there, you can tune at any value. Memory feature, no memory value, no feature here, but here there are several memory features like I told earlier. Maintenance, it is very difficult here, frequent maintenance is required, but here it is a maintenance free for 20 to 25 years. So output relaying program is not possible, here it is possible. And you can see that accessibility of relay from remote place is not possible in terms of with respect to electromechanical relay, but it is possible in numerical relay. Like status of any service values and all, you need to go personal and you have to see that, no down, but here there, so but here it can be available there even by sitting at your panel and all. Safety of personnel, no inadequate safety is there at the remote location. Here there is adequate safety is provided. Space requirement, there is a need of a stock because electromechanical relays are unexpected, any thing or any part may fail, so spares are should be maintained. But here is a, since it's universal design, so minimal spares are required. And again when it comes to the connectivity to the present or any future system such as SCADA and EMS, that is supervisory control and data acquisition, there it is not possible, but here it is possible. So in each and every aspect you can see numerical relay has got advantages. So you can say this is the future of the all power system, you can say, in coming years. No doubt major of things are been replaced, but again you can see still, like I told, there is a research going on artificial neural networks as well as the fuzzy logic system. So if it still it's in development stage, when it has again when R&D is being done on those things. So in future you can expect all numerical based relays.